In the previous video, we learned how to tune PVST for small and medium-sized networks.
So my question is, what is exactly PVST?
If you're working in small or medium-sized business, you definitely... And now, we're going to learn how to optimize enterprise networks.
After watching this video, you're supposed to implement MST in your network. So be with me until the end. In this video, we're going to talk about the practical protocol, which is often ignored by many company experts, the MST, which stands for Multiple Spanning Tree, prevents loops from switches. It also has the feature for using every single link to increase transmission speed if you tune that properly. Do you know how STP works? STP sends BPDU packets every 2 seconds, right? Technically, we have one STP for each VLAN. So imagine if we have a large number of VLANs in a network. For example, we got 50, 100, or even 1,000 VLANs, which means we have the same number of STPs in the network. What happens if 100 or 1,000 STPs send BPDU packets every 2 seconds, and the packets have round trip? I'm talking about the chaos, which causes problems including an increased memory and CPU usage. When the number of VLANs exceed a certain amount, bad things happen to the performance and network infrastructure devices, and then you need to switch to MST immediately. MST uses IEEE 802.1s standard, combine the best aspects from both the PVST Plus and 802.1q. The idea is that several VLANs can be mapped to a reduced number of spanning tree instances, because most networks do not need more than a few logical topologies. As a result, too many VLANs BPDU problem is addressed by MSTI or MST instance. Launching MST is included of several commands like defining MST region and revision number. Please note, write down somewhere to remember that forever. You need to input the same region name and revision number in all switches. I'm going to show you at the end of this video and also in MST tuning episode in the next video. You might ask me why large companies with many VLANs don't use this protocol. Well, the first and the most important reason is the lack of knowledge of the experts in the organizations. And of course, that's harmful for the organization resources. The second reason is fear, a fear of dying. Network specialists are usually afraid of making changes to the network which is working, right? So bro, improve your knowledge and just do it. Another reason I've seen for not implementing MST is that they say our topology is tree and we don't have STP. While I've seen they have more than 70 VLANs and they use rapid PVST by default, but they still keep saying that the topology is tree. We have no STP, we need no MST. Really? Do you know what 70 VLANs mean? It means sending and receiving BPDU traffic from 70 STPs every 2 seconds at one time. Can you imagine that? Let me show you whether tree topology has STP or not. I prepared this scenario in Packet Tracer. We got one layer 3 switch in core and 12 layer 2 switches, and all of the layer 2 switches are connected to the core switch, which is layer 3. Let's check out another thing which show VLAN. I have created several VLANs in this scenario. They are about 40 VLANs, right? And we show spanning tree. Here we are. You can see all the spanning trees that are created for each VLAN, right? So as you can see, even in tree topology, we have one spanning tree for each VLAN. And I'm gonna do something else in this scenario. I'm gonna trace the packets, BPDU packets with simulation. And I'm going to define only SDP, which is BPDU packet. Play. Here we are. These are BPDU packets. And as you can see, all the switches are calculating the BPDU packets continuously every 2 seconds, guys. Now I'm gonna design a scenario. It's like we do it in real and productive environment and setting for the VLANs. And I will show you how BPDU problems happen before MST and what happens after implementing MST. But guys, I'm gonna tune MST in the next video. Alright, let's go. Alright, this is our scenario here, and it is full mesh as you can see, and all the uplinks, the interfaces are connected to other switches are all trunk, right? And as I just told you, I'm planning to create 40 VLANs for each switch and capture the packets to see BPDU traffic, and then launching MST to see BPDU traffic afterwards. So now, if I open the core switch in here with show spanning tree, you can see this is a root bridge. The core is a root bridge, right? All of the trunk ports are P2P type. It has to be P2P type in emulator. Remember that. And if I show VLAN, as you can see, we have no VLAN. We haven't created any VLAN in this scenario. So I start from this switch core to create VLANs. So going to configure mode and VLAN 1 until 40, and with show VLAN, you see that all 40 VLANs are created in switch core, as you can see. So now I'm going to do the same for the rest of the switches, and I'm not going to waste your time, so I speed up the video and then continue this scenario. Now all of the switches have 40 VLANs. Let me write down in here VLAN 1 to 40 for all the switches. Is that right? So before I capture the packets, I'm going to show you what switch is root bridge. I'm going to start from core switch, which show spanning tree with root at the end. You see that? Core switch is all of the VLANs root bridge, right? Root cost for all VLANs is 0. So core switch is root bridge for all VLANs from 1 to 40. Now with show spanning tree, we can check the SDP protocol. Spanning tree enable protocol IEEE. Guys, if we were in real environment, it would write in here rapid PVST by default. But because this is an emulator, it doesn't show you that rapid PVST, but we can set rapid PVST protocol manually. So don't worry about that. And now we figured out core switch is our root bridge. So both of the ports are designated. Basically, we know in networks that BPDU traffic are being sent from designated ports. So we're gonna capture the packets from this port. From this port, start capture and open the Wireshark in here with filter STP, which is BPDU. You can see the BPDU traffic in here. And this is too much. You can see the BPDU traffic, the packets are being sent every 2 seconds from 40 VLANs. Can you imagine that? That's why I told you this causes problems, because all the switches are calculating all the time. So this causes problems like RAM and CPU usage and also for performance of the switches, right? So what's the solution? As I just told you in this video, we're gonna launch MST. So the solution is MST instance. We're gonna enable MST in all switches manually, and all the VLANs are going to be mapped in instance. To enable MST mode in switch, we have to go into configuration mode. Let's configure terminal with the command spanning tree with question mark. You can see other commands with spanning tree mode question mark, 3 modes in here: MST, PVST, and rapid PVST. By default, we have multiple VLANs, so as a result, it is per VLAN rapid spanning tree mode. Because of the traffic of the BPDU, we're gonna set MST and which show spanning tree. In here, you can see the protocol of the STP has been changed, right? It is changed to MSTP, multiple spanning tree protocol, right? I'm gonna do the same for the rest of the switches, speeding up the video. So I have already set all the switches MST protocol. So if I go to any switch which show spanning tree, you can see MST protocol. Spanning tree is MSTP. So all of the switches now are set to MSTP. If I capture this link again, let's capture the packets with STP. As you can see, BPDU traffic problem is resolved. Now if I go to the switch, any switch in this scenario which show spanning tree, guess what? MST configuration, you can see MST configuration in here, and as you can see, MSTI or MST instance number 0 is created by default after setting MSTP, and all of the VLANs from 1 until the end 4094 are mapped in instance 0, right? However, we resolved BPDU problem, but this scenario is not completed yet because we can't use the maximum of capacity. So I'm gonna tune MSTI in this scenario in the next video because I don't want to make this video too long, so I have to say goodbye. Thank you for watching. Don't forget to subscribe me to watch the next videos. It will be so fun. See you soon. Goodbye.